So when I'm given the cosine ratio of positive 5 over 8 in quadrant 4, I know the quadrant, so I know the location of it, so I need to make sure that I draw that in the right quadrant. Now, I'm going to undo this cosine to find the angle, so I need to consider two different angles. Okay, so the two different angles are going to be in quadrant 4 and quadrant 1. So when I draw it in like this, there's my radius of 8. We've got a position of 5 positive, and this position in quadrant 4 is the one I'm looking for. I'm going to solve for the angle. Okay, so I'm going to undo the cosine with an inverse cosine. My input is my ratio, my output is my angle. So I put this into my calculator, I'm going to end up with 51.32 degrees. Now this is a wrong angle. Okay, this is my theta 1, and my theta 1 is in the wrong spot. It is in the wrong position. It's in the wrong quadrant. It's over here. That's not the one I want. So I need to use my symmetry then to be able to find the correct angle. So theta 2 is the angle that I want. Theta 2, I'm going to measure it in this direction. And because of the symmetry, instead of going forwards this much, I'm going to go backwards from 360. So I'm going to do 360 minus theta 1, which gives me 308.68 degrees. Okay, so there's my theta 2, which is the angle that I'm looking for in quadrant 4. Now, you could use negative 51.32, that locates the same position. Okay, so I'm going to put that in here. However, sometimes you're asked for the positive version, so these are just coterminal angles. But there's always a theta 1, theta 2 involved when you're undoing cosine. Okay. So if I want to find the sine and tan ratios, I need to work out the third side using Pythagoras. So I get 64 minus 25, and that's going to give me 39. So I'm going to square root 39. Now again, it's really important that you always remember positioning. It's negative 39, negative root 39. So once I get the right positioning, I can then use that position of negative root 39 over 8 as my sine ratio. My tan ratio is sloping in the negative direction, and I'm going to use rise over run. And I get my negative slope by doing it that way. So again, in this case, we always have to consider two angles. Okay, theta 1 in this case was the wrong position because I know the position, so I'm only going to give one solution, which is that angle there. Okay, these two solutions are the same. They are just coterminal angles. One is measured in the negative direction, the other one's measured in the positive direction. It doesn't really matter because they locate the same position. So here's another one where we can find, we were given the quadrant, we're given the cosine ratio, we need to undo it, so we need to consider two possibilities. So here I'm going to do the inverse cosine of negative 3 over 5. My calculator is going to give me 126.87 degrees. Okay, so 126, I'm going to say that's theta 1, 126.87 degrees. Okay, that's, if I locate that angle, it's going to be this angle here, 126.87 degrees. Now the problem is, this is not in quadrant 3. I want quadrant 3, which is this quadrant right here. Okay, so if I want to find that angle, I need to use the symmetry here to get the same cosine. So this is going to be negative 3, positive 5. Okay, theta 2 then, using symmetry, I can use my reference angle if I like. I'm going to use my 360 minus, so I'm going to go backwards from 360, backwards 126.87 degrees, and I'm going to get 233.13 degrees. Write that in, 126.87, and so my theta 2, I calculated as 233.13 degrees. Okay, so there's my standard position angle, 233.13 degrees in the correct quadrant. It's in quadrant 3. So this is the solution that I want, okay, because I know the quadrant. I'm just going to highlight that. Okay, so that's the quadrant. So once I found that out, I'm going to find my sine and tan for that particular position. In this case, the position is down. So when I use Pythagoras, I'm going down 4. So my sine ratio is going to be negative 4/5. My tan ratio is going to be positive slope. It's going to be negative 4/3, which is positive 4/3. So if we want to find the other trig ratios given one ratio, one ratio gives us two sides, and it only tells us whether we're on which side of the circle we're on, or it only gives us two possibilities that we have to consider when we start with the ratio. So the ratio gives us two sides of the triangle, but we also have to consider that the ratio by itself gives us two different positions. So then we can find the third side using Pythagoras, but we need the quadrant because there are two possibilities for sine. Okay, so, and again, to understand that, I want you to understand that we start with our ratio, okay, our ratio A over B. If we want to use the arc sine, the inverse sine, there are more than one possibility. There's theta 1 and theta 2. And this one here comes from our calculator. Okay, this one here we have to find using symmetry. We need to find. Okay, so that's very important to make sure you understand. When we're going backwards like this, the ratio has more than one possibility when we undo it. Okay, this is when we use arc sine, it only gives us the one possibility. We have to infer the other ones.